Hey everyone, and welcome. If you're a student trying to wrap your head around research design, well, you are in exactly the right place. Today, we're going to break down two of the most important methods you'll ever come across, experimental and quasi-experimental research. Okay, let's jump right in. So just imagine for a second, you've come up with this incredible new way to teach, and you just know it's helping students learn better. But how do you actually prove it? I mean, how can you be absolutely sure that the students' better grades are because of your method and not, a dozen other things? That's the big question we're going to answer. And that question leads us to what is basically the holy grail for a lot of researchers, this quest for causality. It's all about getting to a point where you can confidently say, hey, the thing I did caused this result. It's about forging that solid, undeniable link between cause and effect. Now, in the scientific world, there's sort of a perfect, ideal way to prove this cause and effect relationship. It's what everyone calls the gold standard because it gives you the absolute strongest evidence possible.
And that gold standard is the true experimental design. Whenever a researcher is actually able to use this method, their conclusions are just incredibly powerful. But what's the secret sauce? What makes it so special? Well, it all boils down to one single crucial feature.
And that secret ingredient is random assignment. The beauty of this is its simplicity. It just means that every single person in your study has the exact same chance of ending up in the group that gets your new teaching method or the group that doesn't. It is literally like flipping a coin for every student. Heads you're in, tails you're out. So here's how it works. First, you get all your participants together in one big pool. Then, one by one, pure chance decides where they go. And here's the magic trick. By doing this, you create two groups that are, on average, the same. Statistically, they're equal before you've even done anything.
And this is why it's so incredibly powerful. Think about it. If the two groups started out the same, and the only thing you did differently was give one group your special teaching method, then any difference you see at the end has to be because of your method, right? It just wipes out almost any other explanation.
But, and this is a big but, as perfect as that all sounds, the real world is messy. And a school classroom, it's one of the messiest places to do research. That gold standard often becomes a complete logistical nightmare.
And this right here shows you the problem perfectly. In an ideal world, you just randomly create your groups. But in the real world, no school principal is going to let you just pull students out of their scheduled classes and mix them all up just for your research project. You have to work with what's already there. These intact, pre-existing classes. And this is where the quasi-experimental design swoops in to save the day. The word quasi literally means almost or resembling, so this is almost a true experiment. The key difference, as you can see, is that you're using those intact groups, like Mr. Smith's morning class and Miss Jones's afternoon class, instead of randomly creating your own. Okay, so you couldn't use random assignment. That means you can't be 100% sure the two classes were equal to start with. So what do? Well, researchers have a really smart tool for this, the pretest. By giving both classes a test before the study even starts, you can get a snapshot of where they stand. It lets you check if they were similar enough to begin with.
But even with the pretest, you're not totally out of the woods. See, working with these real-world groups opens your study up to some hidden dangers. We call these threats to validity, and if you're not paying attention, they can totally wreck your conclusions.
And the main thing these threats attack is your internal validity. Now, that's just a fancy term for asking a really simple question. How sure are we that our teaching method and nothing else was the reason the student scores changed? Let's look at a couple of the big threats. So first up is a threat called maturation. This has absolutely nothing to do with your study itself. It's just the simple fact that people, and especially young students, they grow and change and develop over time, all on their own. For example, let's say your study lasts a whole semester. Well, in those 6 months, the students are going to get older. Their brains are going to develop. They might just get better at the subject naturally. So the maturation threat makes you ask, was it my amazing method, or did they just grow up a little bit? All right, next on our list is mortality, which is also called attrition. Now, it sounds pretty dramatic, but don't worry, it just means that some people drop out of your study before it's finished. And this can actually have a huge effect on your results.
Let me paint you a picture. Imagine your new teaching method is pretty challenging. So a few of the weakest students who are really struggling just decide to drop the class. All of a sudden, the only people left in your group are the stronger students. So when you look at the final average score, it looks amazing. But it's not real, it's artificially high because all the low scores just disappeared. And finally, we get to what's probably the biggest, meanest threat of them all for quasi-experimental designs, and that's selection bias. This is the big risk you run when you can't do random assignment. It means your two groups might have been different from each other in some really important way right from the start.
And here's the classic example. Let's say your experimental group is the 8 a.m. class and your control group is the 4 p.m. class. Any difference you see in the final scores might have zero to do with your teaching method. It could just be that the morning students are awake and alert, and the afternoon students are tired and just want to go home. That, my friends, is selection bias.
Okay, so after hearing all that, you might be thinking, well, what's the point? But listen, the answer is not to just throw your hands up and give up. The answer is to be aware, to be honest, and to acknowledge these potential problems. And you know what? That actually makes your research stronger, not weaker.
So, let's put it all together. This table is a fantastic summary. On one hand, you've got the true experiment. Random assignment, super high control, strongest claim to cause and effect. But it's really rare and hard to do in places like schools. On the other hand, you've got the quasi-experimental design. You use intact groups, you have less control, and you can only suggest causality. But it's way more practical, which is why it's the most common design in education.
And that really is the bottom line here. For most of you doing research in a real school, the quasi-experimental design is going to be your best friend. It's practical, it's possible. But what separates a good researcher from a great one is knowing the limits of your design and just being totally upfront about them. And I really want to leave you with this idea. Being aware of all these potential threats isn't a sign of weakness, it's your greatest strength. Because it's what allows you to go beyond just spitting out numbers and instead have a smart, honest, and truly academic conversation about what your results really mean. And at the end of the day, that's what good science is all about.